we go. We're doing 9-4B. Okay, so we're still going to talk about arithmetic series. Now remember, a series is when it's a sum. It's adding up a sequence number. So we're going to talk about arithmetic series, and today our focus is going to be on something called summation notation. We're going to learn a new symbol today. That's always exciting. Summation notation. It is.
It's a nice word.
Okay. So here we go. To write the sum of all these things that we're going to add up, we're going to use this symbol here, which I'm sure you've seen it a few times, especially if you've watched movies that have math stuff in it. Like in the background, they usually like to write that symbol because it looks really like you're a good math student.
If you close off the other side and then draw a little rectangle above it, it's the SAG Village logo.
Okay. Oh, maybe they got it from this. All right. This is a Greek letter. It is in Greek the capital letter for S, which is called sigma. Sigma. And S means sum. It's the sum formula. So this is what you're going to write. So if you have a summation notation, you're going to have things on it, okay? I'll show you what it's going to look like. So you'll have a summation notation like this. You'll have a sigma, and then they'll have to tell you where to start. So at the bottom of this, they're going to say n equals, and they'll give you a number, okay? And that's the number term that you're on. Why are you recording this? No, get that out of here. Put it away, please. No, it makes me uncomfortable. I'm going to take your phone. Bring me your phone. Or put it away. There you go. Instagram Live. Who wants to see this? Nobody does.
Are you still recording?
No, I am. Oh, shoot, yeah. Okay. All right, so n equals, and they're going to give you a number down here, and that number is going to be the n that you are going to start with. It's your starting point, okay? Then up top will be a number also, and that number up top is going to be your end term, the last term. Not term, I shouldn't write that. It's going to be the end of your summation. And inside of here is going to be an explicit formula. So, yep, you're going to need to write an explicit formula. Okay, so that looks really confusing when I haven't given you an example, but let me go ahead and we're going to do an example of this. So, number 1. They will ask you to evaluate. Okay, and you're going to need to know what sigma means. Like if you are in first grade or kindergarten and someone tells you to do this, there are kids in preschool who have no idea what that means, right? They haven't learned the plus sign yet. We all know, because we went through kindergarten or first grade or whatever, we all know that we add those together because this symbol tells us to add. The sigma tells us to also add up a whole bunch of numbers. So it's going to say evaluate from n equals 1 to 3 for 5n plus 1. Okay, and that's what you're given, and you're told to evaluate this. And you're like, what is that saying? That's weird. It is weird. It looks strange at first. You don't really know what that means. This is what it means. We're going to now write the numbers that we need to add up. The numbers that we need to add up start at n equals 1 and end at n equals 3. So I need to find out what it is when n equals 1. So let's plug in 1 for n, and what do you get? 6. 5 times 1 plus 1 is 6. Okay? Then I now need to find out what n equals 2 is. There is no 2 in any of this stuff, but this is from n equals a number to the last number, and it goes, it's all whole numbers. So then you go n equals 2. So now let's plug in 2, and what do you get? 11. And then we'll plug in n equals 3, and we get 16. And that's where we stop. because n equals 3, see this 3 right here? It's telling me that's my last n. So n equals 1, 2, and 3. And then I get my calculator out, and I take that, and I add it up. 6 plus 11 plus 16, or if you don't need a calculator for that, that's great too. And you end up with 33. So you evaluated this and got 33. Okay? All right, let's do some more. Number 2. All right, n doesn't have to start at 1. Okay? So you could have one that looks like this. It usually will start at 1, but let's say it doesn't. It's going to look something like this. N equals 4 to 9. And our explicit formula is n equals 2. And I'm supposed to evaluate the sum from when n equals 4, so the 4th term to the 9th term for this series. This is all arithmetic today, all arithmetic. All right, so here we go. Just go ahead and find them. You know, it's only from 4 to 9. You can find those numbers and add them up. So let's plug in 4, and what do I get? 6. Now I'm going to plug in 5. It's the next n. N equals 5 would give me 7. Then I plug in n equals 6, and I get 8. N equals 7 gives me 9. N equals 8 would give me 10. And n equals 9 gives me 11. Okay?
How many terms do you want to say?
Well, it tells us how many terms. We're doing from term n equals 4 to n equals 9, and all the ones in between. So this right here is n equals 4, 5, 6, 7, 8, 9, and that's where I stop. So this number up here tells me where to stop. All right, and I add those up. Beep, boop, beep, boop, and I get, shoot, I don't know, I didn't do it. Did anyone do it?
51.
51, thank you. 51. Okay, now you're probably wondering, what happens when it's a lot of numbers? Do I really want to write them all out? No, you don't. So here we go. Number 3. Now we learned yesterday that the sum of n numbers for an arithmetic sequence or series is n over 2 times a sub 1 plus a sub n. We learned that. You don't have to memorize that. I'll give that to you on your next test and your final exam. But that's what we learned. And I'm going to use that in the next problem. Because if I have a whole bunch of numbers to add up, I don't want to find them all and add them. I want to use a shortcut, which is a formula. Okay, so we're going to go ahead. We're going to add up the numbers. N equals 1 to 50. And we'll do 2n minus 3. 2n minus 3. Okay, in order to plug this into my formula, I need 3 things. I need to know what n is, I need to know what a sub 1 is, and I need to know what a sub n is. Okay? N is the number of numbers that I'm adding up. Am I only adding up one number? No. How many numbers am I going to add up? Anyone want to take a guess? 50. See, n equals 1 to 50. There's going to be 50 numbers there. N equals 1, n equals 2, n equals 3, all the way to n equals 50. So n would be 50 numbers. Okay? If you were wondering how you get that, well, 1 to 50, there's 50 numbers. But if you did 50 minus 1, you would get 49. You have to add 1 to that to give you your 50th term. All right, what is your first term? Your first term is by plugging in n equals what? 1. If I were to start this formula here, I would plug in n equals 1, and I would get what? Negative 1, right? N equals 2 would give me positive 1. N equals 3 would give me 3, and so on and so on. So my first term is negative 1. What's my last term in this thing? Don't tell me it's 50. So many people will think that it's just this number up here. It's not. I have to find out what the 50th term is.
97.
What'd you get? 97. Exactly. 97 would be the 50th term by plugging in 50 into here. So you're going to plug in 1 to get the first term. You'll plug in 50 to get the last term. And then there's 50 numbers. So now let's go ahead and put this into our sum formula. So the sum of these numbers would be 50 over 2, first number plus the last number. What do we get? We get 25 times 96, 2,400. There you go. Pretty good, right? Not too bad. You want to try another one of those? Another one. Let's do one more of those. Number 4. All right, let's go from n equals 1 to 35. 35. And let's do 5 minus n. 5 minus n is our explicit formula. All right, so you need to find out, first you need to find out what n is. If I'm going to take numbers from 1 to 35 of them, how many are there? 35 of them. Then I need to find out what the first term in my sequence, my series would be. So I'm going to plug in 1, and what do I get? 4. And then I need to plug in 35 to find the 35th term, the last term. So that would be negative 30. Perfect. You have all 3 parts that you need. And now let's plug it into our sum formula. Okay? Sum formula is given to you. You just look up at the top of your page on your test, and you go, oh, there it is. It's 35 over 2, n over 2, a sub 1 plus a sub n. All right, so let's do it. 35 over 2, 4 minus 30, negative 455. It's okay if you get a negative number. Just means you're adding up a lot of negatives, not a problem. Okay, last types of problems. Here we go. Now, you are now going to have to come up with your own sigma guy. This is very exciting. Now, here we go. Recall from your arithmetic formulas that a sub n equals a sub 1 plus d times n minus 1. Or, some of you guys like that one, right? A lot of you like that one. Or the other one, which is the one I like, a sub n equals a sub 0 plus dn. Okay, why am I telling you this? Why do we care? Well, thank you. These are the explicit formula for arithmetic. And if I'm going to put this into a sigma, I need an explicit formula in that sigma. Let's go back to where I wrote sigma. You see where it says right here? Explicit formula. Okay? All right. So, here we go. Number 5. Number 5. Let's do it. Suppose that I have 7 plus 11 plus 15 plus ... all the way to 207. I want to write this series in sigma notation. Sigma notation. And I'm going to evaluate the sum. Okay, write that down. This right here is, a finite series. There's a finite number of terms. We can't see them all because of this ... in the middle. That just means that some of them are missing. Okay? So what I'm going to do is I need to write this in sigma notation. So go ahead. The first thing you want to do is you want to give yourself one of those. Right? It has to go in sigma notation, so write a sigma. Okay, then make it easy on yourself. This is what you want to do. You want to always let n equals 1. Okay? It could be 0, it could be 3, it could be whatever, but if you want to just do it a nice, easy way every time, n equals 1. Now we need an explicit formula for this arithmetic series up here. So what would my explicit formula be? A sub n equals, how many of you guys like the a sub 0 plus dn? Yes, me too. What would the number before 7 be? What are we doing each time? We're adding 4, so it would be 3. So this is 3 plus 4n, right? So that's my explicit formula. You could rearrange it if you want to. You could write 4n plus 3, whatever. It doesn't matter. So I'm going to write 3 plus 4n. And all I'm missing is this last part. I need to figure out how many numbers I'm going to do. Do you remember how to do that? Here's the last term. We want to find out what number term that is, and so we're going to solve for n. You did that in homework last night. This right here is the nth term. It's the last term. So we're going to plug that in for a sub n and find out what the number it is. So subtract 3. Divide by 4. What do you get? 51? 51. So n equals 51. That means that I am adding up 51 terms. This is the 51st term right here. So I put a 51, and that would be my answer. That's the first part. It's kind of like this is part A, right, in sigma notation. And then part B now, you can do it in green, is to now evaluate the sum. But evaluating the sum is going to be nice and easy because you have all the parts you need. How many numbers am I adding up? 51, good, over 2. The first number in this series is 7, and the last number is 207. You go to your calculator, figure it out. Here we go. 51 divided by 2 times 7 plus 207 in parentheses, and I get 5457. Yay, really good. All right, I'm going to let you do one now. Are you ready? You try this one. Okay, let's see if you got this. We'll do this one. Negative 5 plus 2 plus 9 plus ... all the way to 268. I want you to, A, write this in sigma notation, and then B, evaluate the sum. Last problem. I'll let you try it. Start by drawing yourself this sigma, and then start by telling them that, and it's going to start at n equals 1. Next, you're going to need an explicit formula for this, okay? This is adding 7 each time. No. Yes. Adding 7. So if I were to go back in time, this explicit formula would be negative 12 plus 7n. Negative 12 plus 7n. Now, if you use the other formula, you'll still get there. Yeah. But you need to distribute and simplify it. Okay, do you use the other formula?
I use both.
You use both. You should get the same thing. If you use a sub 1 plus d times n, and then you have to distribute and simplify, and you'll get that.
So it should be,
You can rearrange it. 7n minus 12 is fine too. Now I need to find out what that last number is, what term that is. The last term is 268, but what number term is it in my series here? So I'm going to take 268, set it equal to negative 12 plus 7n, and solve for n. So you add 12, you get 280. We actually did this one yesterday. Do you recognize it or no? And then n would be 40. So make sure that you remember to plug 40 in. So that would be your first answer. So I took this entire thing and I rewrote it in this fancy math talk language here, right? All right, now part B says, now we need to find out what the sum is. So the sum is going to be, this part you're pretty good at, right? I feel like you're better at this now because you had it last night, you're having it today. How many numbers are we adding up? 40 numbers. And the first number in this series, negative 5, good, and the last number, 268. Go to your calculator. What, you got it already? Good. Got a good grasp on this stuff. 5260? Good, okay, nice. How many of you guys got that before I did? Oh, yes. A lot of them did. Okay, all right.